All right, let's go ahead and get started. Hi, everybody. Thanks so much for joining us today. My name is Emily Hamilton. I'm the Communications Coordinator here at SplashLink, Water's online platform. With us today to talk about innovations in water infrastructure and technology, we have Steve Frenkel, who directs strategy, operations, and programs to advance innovative water research and technology as current executive director. Prior to this appointment, Steve was previously a management consultant helping power sector clients develop wind and solar energy projects. He led the Midwest office of the Union of Concerned Scientists and directed Midwest operations of the financial health. Sorry about that. He served as Chief Policy Advisor at the Illinois Environmental Protection Agency, Senior Advisor for Energy and Environment, Deputy Chief of Staff in the Illinois Governor's Office, where he oversaw energy, environmental, and climate policy. Steve holds a master's degree in public policy from the University of California, Berkeley, and an MBA from the University of Chicago's Booth School of Business. Additionally, we have some individuals from the City of Chicago's Department of Water Management, including Alan Stark. He's the Managing Deputy Commissioner for the City of Chicago Department of Water Management. As Managing Deputy, Alan is responsible for the operation of not only the Jardine and Sawyer water purification plants, but also all 12 pumping stations and the chemistry, microbiology, and microscopy labs. He oversees more than 600 employees and is responsible for maintaining compliance with EPA regulations. As part of his duties, Alan responds to calls 24/7, 365 days a year. Alan has been with the city for 30 years and is a Class A public water supply operator in the state of Illinois. Eduardo Salinas is the engineer of water purification for the Bureau of Water Supply. Eduardo oversees both the Jardine Water Purification Plant and the Sawyer Water Purification Plant, which combined have a capacity to pump 2.1 billion gallons a day. Eduardo has worked for the city for over 20 years and is a Class A public water supply operator in the state of Illinois. Andrea R. Holthouse Kutz, PE, is the water quality manager for the Bureau of Water Supply, where she is lucky enough to spend her days working on her passions: drinking water quality, lead corrosion, and water meters. Andrea has been with the City of Chicago Department of Water Management since 2004. Andrea has her PhD in civil engineering from the University of Texas at Austin, and is a licensed professional engineer and Class A public water supply operator in the state of Illinois. So we're really excited to showcase all the expertise that we have here today. And without further ado, I'm going to go ahead and hand it over to Steve.
Thank you so much, Emily. This is Steve Frenkel with Current, and it's a pleasure to be here on the SplashLink webinar. Thank you so much for the opportunity. We want to introduce you to Current and to our close partners, the City of Chicago Department of Water Management. And I thought I'd walk you through Current as a new water innovation organization based in Chicago, who we are, where we came from, our core programs, and how we're trying to advance innovation in the water sector, including working with utility partners and solution providers. So a little bit of background. So give you a sense of our mission and our background. Our real focus is delivering advanced research and market-driven innovations. We recognize there's a lot of barriers to commercialization in the water industry. We all know there's historic risk aversion, and it's difficult for new technologies to get to market efficiently. Current is focusing on bridging the gaps to help overcome those barriers. We were launched in 2016 as a partnership with the City of Chicago and our Metropolitan Water Reclamation District, as well as in partnership with World Business Chicago, which is an economic development arm of the City of Chicago. If we go to the next slide, we'll see that our partnerships are vast. Even though we're a new organization, we've established strong relationships in the corporate sector amongst research institutions, utility partners, and other nonprofits, all with a shared passion and focus to helping innovate in the water sector. What we've created here at Current is a solutions platform that's founded on 3 core programs: Current Research, Current Demonstration, and Current Connect. And we think of this solutions platform as a tech-to-market pipeline, a way for innovation, whether it's basic and applied research or new discoveries from innovators, to get to market efficiently and serve the needs of utilities and industrial water users. And we think of these 3 integral programs as having synergies that can pull innovation from basic science and applied research and innovation to the marketplace efficiently. So with Current Research, many folks know that Chicago is home to many world-class research institutions that you saw on the prior page. Current's founding partners include Argonne National Labs, which is part of the Department of Energy, the University of Chicago, Northwestern University, and the University of Illinois, both their Chicago campus and the flagship campus in Urbana-Champaign. Current is leveraging the world-class research capacity and innovative strength of these research institutions and bringing them together to create a world-class center of excellence in water research. Because Current is focused on solving problems for utilities and industrial water users out there in the real world, we're really trying to help our research community focus on solving those practical problems. Current's nicely positioned because we understand the marketplace and we can help our research partners understand opportunities to leverage their incredible research capacity and innovative capacity. So the way Current Research works is we bring opportunities to our research partners to partner with industry, to partner with utilities, and pull innovation from those research institutions towards the market. Our Current Demonstration Program is really the heart of what Current is all about. One of the gaps that we see in the marketplace is that there's really a lack of capacity to focus on technology scouting, to find innovations that have broad market relevance that could scale and grow, and to de-risk those technologies and validate them in a rigorous way so utilities and industry have confidence in those solutions and can have the information and insights they need to better deploy those technologies. So I'll explain a bit more about how Current does that in a moment. But Current's focus is really trying to bring technology to market more efficiently, de-risk it, and validate it for end users, whether those are investors, utilities, or industry. When we see Current's role in the marketplace, we think about the technology development process through the lens of how the Department of Energy or sometimes NASA might think of it. Many folks know of what are called technology readiness level indicators. And you'll see on this slide, TRL1 all the way on the left and TRL9 all the way on the right. And this technology readiness level scale really is indicative of how commercial ready a new innovation or discovery is. And so something on the far left side, TRL1, is really a basic discovery or basic scientific principle that has been developed at a research institution and clearly is just at the conceptual phase, is very far away from commercial readiness or application. And as you move from left to right, you can see that the development stage from basic research through R&D to scaling up a technology to the point where it can have some exposure to the market, can be tested and validated by real users, and then move its way towards commercialization. You'll see that there are other institutions that are highlighted here in these bubbles or in these circles, indicating where along this commercialization journey these other institutions focus. So research institutions clearly focus in these early TRL level technologies. Other organizations like LIFT from the Water Environment Federation or the Water Research Foundation tend to focus on slightly more mature technologies or discoveries approaching the TRLs level 4 and 5. Then you see there's a big gap between those sort of mid-stage technologies and what the marketplace is really looking for in terms of end users. We know because of this risk aversion that folks are looking for proven technologies where the technology risk has been essentially reduced as much as possible, and maybe you're looking at execution risk or maybe a little bit of economic risk, but the technology risk has really been well understood and documented and reduced. And so engineering firms and end users that they work with typically look for those mostly de-risked and proven technologies. So you can see there's a gap between these TRL level 5 through TRL level 9 opportunities. And we see Current is helping to bridge that gap through the programs that we're discussing today. Why is this important? Well, we know that technologies in general face a struggle in terms of getting to market. You'll see along the top, this is a different graph, but it really speaks to the same journey from basic science to full deployment. And you'll see that as technologies grow, they really experience challenges in terms of their cash flow and ability to scale and grow and get market traction with customers and end users. And so in this valley of death, in the water industry, as I think all of you know, it's deeper and longer and maybe wider than in other industries, making it's even more important for an organization like Current that has the ability to find, de-risk, and validate technology to be present in the industry and help overcome some of these barriers, working with our clients and our members. So how do we do this? In the Current demonstration program, we have a 4-step process to identify new technologies, rigorously review them through an application process where we understand the basic mass and energy balances, technology inputs, economic assumptions, and then technologies that pass that initial screen move on to what is the heart of the program, which is really our technical and economic assessment and market fit analysis. At Current, we have an internal engineering team that is capable of conducting this kind of rigorous analysis that really helps get deep visibility into the operational and technical assumptions and the economic value proposition of new innovations that are trying to get to market. And technologies that seem to be promising, that meet our hurdle rates and our performance standards, and that have a demonstrable fit with our end users and clients, such as the Chicago Water Department, can move on to physical testing and pilot testing in partnership with our utility or industrial partners. And the results of our technical and economic analysis or assessment provide important insights into the design and structure of a pilot project. The sensitivity analyses that we do provide insights into important variables around performance that can help inform the proper design, scale, and duration of a pilot test. Current tracks the process and is a partner in that physical testing or pilot testing, and we collect the data at the end to refine our techno-economic assessment to improve its accuracy from a bench or desktop analysis, taking into account real-world data and actual performance. The technologies that emerge from our demonstration program have an opportunity to scale and grow through connections in our Current Connect program. In Current Connect, we're able to help young technology companies find beachhead customers, find distribution, find financing, and elevate the brand awareness of those new technology companies as well as our members. We see Current Connect as an essential part of the commercialization process. Once we have validated technologies, how can they be connected with the end users and customers that they need to generate revenue? And how can they get the right kind of advice about how to grow and scale their companies? So we see Current as an essential innovation partner in this water innovation ecosystem. In this graphic on the right, you'll see some of the essential players in the ecosystem, and Current sitting in the middle, providing connectivity and being a catalyst for innovation. So no matter where you sit in this journey, whether you're a utility or industrial end user looking for solutions, Current can be your innovation partner to find and de-risk and validate those solutions. If you're a researcher and you have innovation and discovery that you're trying to get to market, Current can be your partner in helping to find a path to market, understanding market needs. And if you're an investor looking for de-risk technology to help grow and scale, Current can be your innovation partner. So we see that ourselves as a third-party independent voice for innovation and for technology validation for the industry and all the players in it. One new line of service or business that Current is entering is really seeing ourselves in leveraging this partnership relationship as an innovation partner and business development partner for our members and clients, including utilities and industry. And in this line of service, we really start with the market argument or purpose for technology. What does the end user need? What is the problem they're trying to solve? and how can Current be a source of validated solutions to meet those needs. So we see ourselves as augmenting the internal capacity of organizations like the Chicago Water Department that can take advantage of our view on the market. We have an internal database of technologies. We work with strategic advisors that are experts and leaders in the industry that together give us almost complete visibility, not only nationally, but globally in terms of innovations that are out there and looking for customers. We can then pull those innovations through our validation and solutions platform, de-risk them, and give end users like the Chicago Water Department greater confidence in the new technologies that they would like to consider so they remain innovative. As we talk about techno-economic analysis, that's really essential, and this slide just restates a bit of the dynamic between the innovators and end users and the value proposition that this techno-economic assessment provides. We see that as a differentiator for Current. We found that whether they are utilities that are publicly funded, may not have the staff capacity or bandwidth to have a comprehensive view on technologies in the marketplace. We've also found with our industrial partners that there's a similar challenge. People are busy running their businesses and they may not have the bandwidth or visibility in the marketplace to find and de-risk solutions on their own. We see Current as filling that gap for them. In terms of technologies of interest in working with the Water Department, what we do is we go through a needs assessment with our clients and our members to understand the solutions or the problems they're trying to solve. And then we go to the market and try to find and de-risk those solutions. And this is an example of some of the conversations we've had with the Water Department to understand their needs and start to de-risk solutions for them. So I'm going to stop there. And are we taking questions now, or are we waiting? Okay, so we're going to wait to the end to take any questions. And I'm going to turn it over to the Chicago Water Department and Alan Stark.
Okay, let's bring our slides up. First of all, I'd like to thank you for being on this webinar. And we're going to start off a little bit of what water management does. And I'll have one of the smartest people in the world talk about our department. Her name is Andrea Putz. She is a great researcher for us, and she's going to talk about our facilities, you know, and how we treat water. And then after that, I'd like to talk about Current's role with us a little bit more in detail. And then after that, I'd like you to talk to, you know, one of the second smartest person, that's Salinas, about what he would like to do with some of the stuff that he's learned through Current. So here we go. Here's Andrea.
And with that intro, how could I fail? So this is Andrea. I just want to talk a little bit about a little background about our department. You know, kind of what we do, the Chicago water system. We are always looking at source water protection. We're always monitoring Lake Michigan, and that's because that is what we use for our drinking water. So in terms of drinking water treatment, we are looking at water quality. We're treating the water. We have our own certified microbiology and chemistry laboratories. Once that water is treated, it's distributed to all of our customers. So we look at water pumping, we look at our operations and distribution in terms of water main maintenance and engineering as well. We also have our combined sewer system. So we're in charge of maintenance, operations and distribution, as well as engineering for those sewer mains. Once that occurs, once we have collected the combination of wastewater and stormwater, it goes to the Metropolitan Water Reclamation District, our sister agency, for wastewater treatment. Currently, we have 2 crib structures in use, pictured. One of the crib structures is pictured there to the right. We have 2 of the largest conventional water plants in the world. That's the Jardine and Sawyer plants, formerly known as the South plant. We have 12 pumping stations, 9 of which are electric, and 3 of which are still steam power, that is. And unlike a lot of our neighboring utilities, we have no elevated storage, which is a little unusual. That means we're pump on demand. On the plus side, that means that your water is always as fresh as it could be. We have about 4,300 miles of water mains that we need to maintain, actually, and also about 4,600 miles of sewer mains as well. We also need to maintain fire hydrants and water valves. So it's a lot of maintenance work. We serve not only the city of Chicago, but 125 suburbs. So pretty much anyone, if you look at the little map in the lower left-hand corner, pretty much every suburb around the city of Chicago is served by us, by lake water. And it ends up being about 5.3 million customers, or about 42% of the state of Illinois, with about 490,000 water accounts. Everything we do, we take very seriously, as we know that every treatment change we make, every new technology we add affects a lot of people. Looking at our drinking water treatment overview, it's conventional treatment. So we add chlorine for disinfection. We add fluoride, state mandated, to help fight tooth decay. We do use alum and a polydadmac polymer to settle out impurities in the water. And we use blended phosphate for corrosion control to form a coating inside the any metallic service line. We do, as I mentioned, have our on-site laboratories that test samples not only from raw water, but treated water and everywhere in the distribution system. We've always got a finger on the pulse of our water quality. And our system capacity is about 2.1 billion gallons a day, which is pretty impressive. 1.4 billion gallons a day being from Jardine. So we have a very aggressive capital improvement plan, started about 2012 for 10 years to try to replace 880 miles of water main, which, if you're familiar with what typical paces are for water main replacement, is a very significant mileage. We also are looking to rehab or replace about 700 miles of sewer, just in terms of trying to keep up with what we had been installing about 100 years ago as Chicago's population grew. We are also hoping to line 95,000 structures and design the conversion from steam to electric of 4 pumping stations, as well as the actual conversion of 3 of those. One of our pumping stations, Springfield, will go through as our first one that we've accomplished so far. Unlike most other water utilities, we actually are not fully metered. We do not have water meters on every one. We've got all the big guys. When we started a voluntary water meter program, we were about 80% of our finances were metered, but a lot of the single family and 2 flats weren't. So our goal was to install over 200,000 water meters by 2021 to get us caught up. As it is right now, we've installed over 100,000, and we are actually about half metered, half non-metered in terms of the number of service accounts. In order to accomplish all that, we had to gain the support of a lot of people. We had to educate and inform both our own employees, our customers, the unions, the aldermen, all the way up to the mayor, to garner the support and help everyone understand the need for all these capital improvements. We had to also get a rate increase. We did 4-year rate increases, 25%, and then 3 years of 15% on the water side. And then we increased our percentage of sewer all the way up to 100% by 2015 to help fund all these improvements. We got a lot of cooperation, not only from the unions, but also other departments and agencies, because I think, as any other utilities on the line might know, coordination with any other underground utilities can really save a lot of money in capital programming. So this is the example of one of our pumping stations, Springfield. This is the first one that was converted recently, that was converted from steam to electric power. As you can see there by the cost, $70 million. This is not a small project. This is not a small undertaking. It requires quite a bit of capital encumbered at once. So you really need to make sure that you plan this wisely. It does include about $29.6 million in qualified energy conservation bonds, which is super helpful. But the savings that we get from this is about $4.5 million annually, both from labor reduction as well as energy cost reduction. It took about 6 years, and the design involved as much green construction and green technology as we could put into these as good demonstrations of what you can do with green design. So it involves solar panels, a green roof, permeable landscaping, And this is a theme that we do with any construction project that we have these days, is to try to be as green as possible.
Okay, yeah, this is Alan Stark, and I'm going to kind of expound a little bit on the pumping station, if I can go back to that. So Springfield basically is complete into what we have done to convert from steam to electric. Currently, we're looking at the conversion of Central Park pumping station, and that's probably of a tune of approximately, it's like $89 million. So it's about the same size facility, and we think it's going to take about 6 years. There's a lot of lessons learned from this, but every time that you do a large conversion like this, it's not cookie cutter. So everything here becomes a challenge, and you have to have challenges because you have to be live all the time, because these facilities have to supply water, and when you change out basically steam to electric, you're still maintaining the high pressure boiler systems as you're putting in these electric motor systems. So these become a challenge. And as we talk about challenges, so our biggest challenge is current. No, sorry, Steve. But anyway, no, but what's really refreshing is the collaboration with Current. And one of the things that we have done with Current, and it's been about a good year that we've been working with Steve and his crew, was to try to identify certain issues. And I've gone to my professionals within my facilities or within the department and have come up with, some key task areas that we would like to focus on. And Steve has brought up many ideas and has tried to bring us new innovative technologies that are out there, and maybe we can apply some. And that'll be pretty much discussed later with Mr. Salinas after I kind of go through this list. But Steve had us in a room for about 2 days, beating us to death. But anyways, sorry, Steve. But we had to really come up with, I mean, he had, everything up on the boards, whiteboards, and he was, being the taskmaster as he is. But anyways, what ended up happening, we came up with, a few ideas. And as you can see here, we looked at distribution systems. And then with that, underneath that, we kind of came up, what is our issues with that? New coating technologies for lead services. We are interested in what that is because, as you know, with Chicago, we do have an issue where we do have lead service lines. And one of the things that we're looking for in that is part of the rules that are out there within the state as well as the federal government is that you have to ID all your service lines. So basically you have to have an inventory. And what's the easiest way to have an inventory without to put a hole in the ground to identify the service that's there? And so we're looking for technologies that we can look and see what sort of services are out there without digging. Is there some sort of special x-ray or something that we want to look at? And so Steve is looking into that for us. Preventative maintenance, a big thing here for everybody. You know as well as I do. We like to look at how our operations are doing and to forecast. And you have to do a lot of number crunching, and that's the analytics behind it. So you can forecast and process what you need to do, and then you can put things in perspective so you can come up with a good maintenance plan for all facilities. And if you really think about it, for my bureau alone, just for my maintenance alone, it's $80 million a year. I fly through that very quickly, but I like to use it, as preventative, not a knee-jerk reaction. Same thing goes with plant process. It was another thing that we came up with. In the plant process, is there new efficient technologies for mixing? Whereas you have these large mixers that just spin for us, we have these large wheels that move, and there's a lot of energy, a lot of mechanical structures. Is there anything out there that would help us to have an efficient approach for mixing chemical within the water itself? Resource recovery, this is one thing that I kind of like, because one of the things is and if anyone is from MWRD, no offense, but anyways, you get our materials, and basically I like to recover some of the good products out of that material, or our sludge, let's say, and then we can sell that off and make money and just kind of turn that back into the system for capital costs. Rebuilding, it's great. And then the one thing for Andrea, water quality testing, the development of rapid analytical field tests for metals such as lead, organics, and biologics. And finally, lead testing. See, the idea with lead testing at this point is if you do a test, you grab a sample, you bring it to a lab. They do have test kits out there that you can do, but it doesn't take into account particulate matter that's in there that could be of lead. So we want to be able to find something out there that, okay, I could pull a sample off of a tap right away and get the full analysis right away. That can be certified. So that was one of the bigger approaches. So in this meeting that we had with Current, we actually identified, we had a lot of different ideas. We actually narrowed it down. There was a lot of collaboration, and also since I am in charge, I don't have the head voice to it. Actually, everyone had an equal voice, which was a good thing. I thought it was. So in this process here, I'm going to have Ed talk about this. This is one of the things that this is very passionate to him. And Ed Salinas, he's in charge of both treatment facilities. And the idea with Ed is that he wants to make life simpler, in terms of treatment and getting his analytics. And he's into that. I'll tell you, he's the whiz kid geek out of SCADA and out of spreadsheets and databases. So here's Ed.
Thank you, Alan. My name is Ed Salinas, and like Alan described, my job is the responsibility of the filtration plants, and these facilities have a lot of equipment, computers, and stuff like that. On this slide, there's a couple pictures. On the left, we have the controllers for chemical feeds, and these are information that, for example, our computers have. Our computers are continuously tracking what the feeds are, and when we make changes, this is what we use to do that. And then on the right-hand side, we have these are flow meters. This is half of the flow meters at Jardine. And we use the water flow meter to determine how much chemical to feed, because when we feed these chemicals, it's based on dosage. So we need to know what the water flow is in order to properly dosage the chemical feed. And this information is also, meaning the flow, is also in the computer. So we're collecting a lot of data. We're continuously monitoring this. However, at current time, these things are looked at, modified, tweaked manually. And we have control center personnel whose job is to do this, but this is one of many, many other things that they do. And one of the things that we're pursuing here with the help of Current is to say, okay, we have all this data, it's live information, now we want to integrate it in some kind of logical way to ensure that we're optimizing the dosage, that we're identifying any failures. I mean, unfortunately, there's times where these things fail, and it takes a while before we identify it and know about it, and then we lose some of our water quality capability there and stuff. So the stuff on the left is stuff that, it's been around since the 60s or earlier. The stuff on the right, that's more modern, but now we have the ability to take those information from both devices and build something that can, you know, interpret these logically. So that's an area that we believe there's a lot of benefit that we can get from, and an area that we're pursuing with Current. We go to the next slide, please. Another area of challenge is all this data that I spoke of earlier is all within the facility. There's a very high need to ensure that with all this information that it doesn't go out, or more importantly, that other outside influences don't make changes to our controls, if you will. This is all internal. It's isolated from everything else. There is no web connection to this. However, we have lots and lots of information that we use and we collect, and a lot of this information is used, for example, for reports. And we spend a lot of man hours going through this information and collecting it in spreadsheets and building these reports. And again, we feel that if we could move some of this information into in a secure way to an administrative network, now we would have the ability to collect information from other sources, such as pumping stations, maybe another facility, maybe lab inputs, and so on. And we can start putting some logic into what this data means and create these reports in a lot of ways in almost automated form, where we do our checks and we have our explanations in there, instead of right now using so many man hours and doing a lot of repetitive work and checks and stuff like that. So the challenge that this diagram represents is a potential solution of how to move data from the facility into administrative network, where we can use these tools and collect additional information to put the rest of the puzzle together. And this particular picture, I kind of stole it from Waterfall, who offers a solution that we could potentially use. Homeland Security does help us with advice. They don't mandate exactly how we do things, but we do listen to them, and we want to kind of run it by them and see if there's any things that we're missing. And again, Current is also helping us with this challenge of coming up with a safe way of moving information from SCADA to administrative usage. So these are kind of a bird's eye view of a couple of things that we're looking at. They're kind of on top of the list of things that we need. And I don't know, that's pretty much from my end.
So if you can imagine, if what Ed just spoke about is pretty much all our SCADA systems are offline. And for us to bring it all together, we want a safe, secure approach. So you don't get what you see out of what happened in Atlanta and some other utilities that have had issues of intrusion. So we're very serious about security. So anyways, from Chicago's point of view, thank you very much, and I'll give you to Steve.
Great, thank you, Alan, Andrea, and Ed. And then we want to invite Emily, our MC, to come back on the line and see if we have any questions from participants.
I'm not sure Emily's still on. So this is Jackie Blair with Current. If you're on the line and you have any questions, please feel free to enter them into the chat feature on the right-hand side of your webinar.
So while we're waiting for folks to submit a question or two, if you're interested in learning more about Current and our services, our website is currentwater.org, and we have all the information on our programs and membership and our innovation partnerships, as well as our technology application. If you are an innovator and you're interested in learning more about how we can help you commercialize your technology and match it with end user needs, that would be a place to look. If you're a utility or industrial water user and you are looking for validated or de-risked solutions, we can be a partner to help you solve those problems. So please reach out to us. We'd be happy to talk to you. While we're based in Chicago, and we certainly are leveraging the infrastructure and institutional assets of Chicago, we think of ourselves as a borderless organization. We're looking for partners and clients wherever they happen to be. We have strong partnerships with innovators and institutions in Israel, for example, with the Technion Institute for Research, National Water Utility, water carrier of Israel called Mekorot, and the Israeli Ministry of Economy. And so these are just examples of how Current is reaching globally to try to support innovation, technology commercialization, all the problems that end users are facing. At this point, we don't have any questions submitted. So I think we're going to thank everybody for attending and thank the Water Department for their participation and their support for Current. Oops, we have actually a couple of folks. Okay. So anyway, we thank you for your time today. And if you'd like to get back in touch with us, all of our email addresses are online at currentwater.org. Thanks so much for participating in the SplashLink and Current webinar today. Have a good day.